In this lesson, we're going to be taking a look at finding cube roots. It's just the logical continuation of our last lesson on square roots. So your goal is to understand the concept of cube roots and to also understand other roots. Now, just so you know, your classwork and homework will not be about other roots beyond cube roots, but it's a good place to talk about it just so that in the future you know what it's all about. So let's take a look at this geometry problem. How would you find the volume of this cube? Now, hopefully you remember from a previous class that to find the volume of a cube, all we have to do is find the area of the base, which is 3 times 3, and multiply that area by the height, which is also 3. So in other words, our problem is 3 times 3 times 3, or 3 to the third, or 3 cubed. So just like we call something to the second power squared, this is why we call something cubed, because we're literally finding the volume of a cube. Now 3 to the third power, or 3 times 3 times 3, is 27. So this problem would have an answer of 27 cubic inches. So now what we want to discuss is, what if it was a similar problem? What if we had this? How would you find the side length of this cube, knowing that the volume inside is 64 cubic feet? Well, we just want to take the opposite of what we were doing here. In other words, what times what times what would be 64. Okay, so in this case we have some unknown. Now in this case though also we're talking about a cube, so whatever the side lengths are on all three sides, they're all the same, so let's call them n. So really this problem becomes n times n times n equals 64, or n cubed is 64. So what we want to do is we want to reverse the process. Like most things in math, everything has its opposites. Multiplication has division. Addition has subtraction. For powers or exponents, we have roots. So just like with square roots, we have cube roots. And for this, we use the same radical symbol. Except, if I just use this symbol, we think this is square root. So to show that this is actually a cube root, right here in this little divot, you'll see a 3. This means we're looking for the cubed root. Now, what I do to one side, I do to the other. So just like with squares and square roots, cubes and cube roots cancel each other out. We get n. And then I just have to think to myself, what times what times what is 64, just like we were talking about here. And in this case, it turns out that it's 4. So this is a 4 foot by 4 foot by 4 foot cube. And this is the concept of cubed roots. Okay. So what we've learned is that, just like with a lot of other things in math, exponents have their opposites. That in this case, x to the power of n and x to the nth root x are inverse operations. In other words, for our example here, our two opposites were x to the third, and over here, the cubed root of x. So basically, that's how we do anything beyond the power of 2. Now, we're not going to do it in our work like we talked about, but if I gave you something like n to the 5th power, the opposite of that would be to take the 5th root of n. And so to denote that, we use our radical symbol with the little 5 here in the corner. And it goes on forever. If I want to do n to the power of 10, but later in the problem I needed to undo that move, I would do the 10th root of n.